Yo guys, welcome back to this channel. Nice to see everyone again. And make sure you have hit the subscribe button for more informative video of this channel. And for this video today, we'll talk about the chemical reaction of carbonyl. For the topic 6.4, this will be the part 1 of this subtopic. Okay? So in this chemical reaction of carbonyl, we'll discuss 3 subtopics. The first one is we are going to look at why carbonyl is actually reactive. The second, we'll look at the nucleophilic addition of carbonyl compound. Last but not least, we'll look at the reduction of this carbonyl compound. So these are the 3 things that we are going to cover in this video. So let's jump straight into why carbonyl compound is reactive. So everybody knows that carbonyl compound looks something like this. We have the presence of your C double bond O as your carbonyl group. So that is your carbonyl compound. And why this carbonyl compound is reactive? The reactivity starts because oxygen over here is more electronegative. That will cause the oxygen to be partially negative. Partially negative means the electron will be moving towards the oxygen. Therefore, your carbon will then be partially positive. Why your carbon will be partially positive? Because the electron right now will be more on the oxygen. Because your oxygen is more electronegative. Causing a partially positive and a partially negative N in the C double bond O. And you know that in the double bond, you have the presence of your sigma bond and also pi bond. Knowing that the pi bond is easier to break. So we know that this double bond can break easily to become single bond. And since your carbonyl compound right now is a CO, and knowing that your oxygen will be partially negative, and your carbon is partially positive over here. And what will happen is, you can form a new bond over here, and who will go in and sit with your partially positive carbon? Definitely your nucleophile. Alright, your nucleophile that holding the negative charge will be the one that go in and form a new bond with your carbon positive. Alright, so your partially positive carbon will be accepting a new friend, which is your nucleophile. Therefore, your carbonyl compound will undergo nucleophilic addition. It's an addition over here. Why is undergo addition? Because you are forming a new bond, the carbon and the nucleophile. So when you form a new bond over here, that is your addition. It's a nucleophilic addition because the one that will go in and form the new bond with carbon positive is your nucleophile. So your nucleophile will get the name and become nucleophilic addition. So bear that in mind, your carbonyl compound can undergo nucleophilic addition due to the presence of partially negative and partially positive N of the C double bond O. Simple. Always remember one thing in chemistry. So when you have a partially positive, you must have someone partially negative. When you have a partially positive N, you must always attack by a negative species. Okay? Simple. And we have 2 nucleophilic addition that we will talk about. The first nucleophilic addition is the addition of HCN or KCN or NaCN with the presence of acid. So in your equation, you will have your C double bond O plus with your NaCN with the presence of acid. Or you can have your carbonyl react with your KCN with the presence of acid. Or C double bond O plus with HCN with the presence of acid. Everybody will give you the same product over here later on. The only thing is that make it different is you are using different reagent. Okay? And the second nucleophilic addition is the addition of acidified water. So acidified water over here represent H2O, H+. That is your acidified water. So you can have your C double bond O react with your water with the presence of H+. So that is the addition of acidified water into your carbonyl compound. What will be produced? And guys, since it's a nucleophilic addition, I think what most important over here is who is the nucleophile. So you must identify who is your nucleophile in every reaction that we are going through later on. So let's jump straight into the first one, which is your addition of HCN or KCN or NaCN with the presence of H+. Let's see what happened. First and foremost, if in your alkene carbon-carbon double bond, we focus on the carbon-carbon double bond. In your alcohol, we focus on the carbon that holding OH. So in your carbonyl, we will focus only on the carbon that holding C double bond O. And I hope you remember that your oxygen will be partially negative. Your carbon over here is partially positive. Reacting with your HCN, knowing that you produce H plus and Cn minus. So logically, nucleophilic addition reaction. Who is the nucleophile over here? Your nucleophile will definitely be your Cn minus. That's why you realize that your carbon will have a new friend, which is your nucleophile Cn minus. The Cn minus will go in and attach to the carbon that is partially positive. That is the new addition. And your O that is partially negative will be forever taking in the H plus to become OH. So you can see that the double bond right now will become single bond, and the carbon will have a new friend, which is your nucleophile, and form a C single bond Cn. And this product will be named as cyanohydrate. The same carbon that holding OH, the same carbon that holding Cn will be cyanohydrate. While the nucleophile of this addition process is your Cn minus. Okay? Simple. Only focus on the C double bond O. Let's look at some example. So, we focus only on the carbon that holding C double bond O. The rest of the thing doesn't change. So, let's say I react with my KCN with the presence of acid. Knowing that the rest of the group doesn't change. So, we recopy everything that shall remain the same. Just copy that. The carbon that holding double bond O is this guy. So what is happening? Your oxygen partially negative, your carbon partially positive. You have your K plus, you have your Cn minus. So knowing that the oxygen will be forever taking the H plus, so you form a OH. So the carbon positive will be taking your Cn minus. Alright? Simple. Focus only on one person, the carbon holding double bond O, your carbonyl group. Next example, you have a cyclic over here, same thing. We focus only on the carbon that holding C double bond O. Let's say I react with my NaCN over here with the presence of H plus. And what happened, ladies and gentlemen? Oxygen is partially negative, carbon over here is partially positive. Na will become Na positive, Cn is your Cn minus that we are looking at. And most important thing right now, the group that doesn't change shall remain unchanged. Only the carbon that holding the double bond O will become single bond OH. And the carbon will have a new friend, which is your Cn minus. So the changes is your double bond O will become single bond OH. Your partially positive carbon will holding a new friend Cn. Alright? And who is the nucleophile for both of these examples? The nucleophile is Cn minus. Alright? Simple. That is the first nucleophilic addition that we look at. Let's move to the second nucleophilic addition. The second nucleophilic addition is the addition of acidified water, which means you are using H2O H+. Same thing, we focus only on one person, the carbon that holding double bond, O. Knowing that your oxygen again partially negative, your carbon again partially positive. Your water will be split into OH- and H+. And your partially negative oxygen will be forever taking the H+. So you form a OH over here. The double bond will break and become single bond over here. Alright? And your carbon will have a new friend. And the new friend must be a nucleophile. So who is your nucleophile over here? Your nucleophile is your OH-, the only nucleophile that you have in this reaction right now. So OH- will go in and your product will be named as gem-diol, the same carbon that holding two OH group. That is your gem-diol. Okay? And obviously over here, the nucleophile of this reaction will be OH-. OH- will be going into the carbon that is partially positive over here. Simple, easy. And a kind reminder over here, we only focus on the carbon that holding the C double bond O, your carbonyl group. Let's jump into your first example. That is my C double bond O. I react with your H2O with the presence of acid. And guys, those that doesn't change remain unchanged. So we copy the whole group that doesn't change first. So everything that doesn't change shall remain unchanged and recopy that correctly. And that is my carbon that holding C double bond O. So everybody knows that oxygen partially negative, carbon partially positive. Your H2O will become H+ and OH-. Everybody knows that the H+ will be go to the O-, forming OH, while the C partially positive will be taking in the OH-. So you form your OH again. Simple, easy. Next example, you're having a cyclic, but it doesn't matter because we only focus on the carbon that holding C double bond O. React with acidified water, H2O with the presence of H+. Knowing that the ring will not change because the only thing that change is the carbon that holding double bond O. And this double bond O will become partially negative on the oxygen and partially positive on the carbon. Water will produce H+ and OH-. Double bond O will become single bond OH. And the carbon will then accept the nucleophile OH-, forming your gem-diol. Simple. And the nucleophile for both of this reaction will be OH-. That's why you become nucleophilic addition because the OH- is added into the carbon double bond O. That is your nucleophilic addition reaction. So I hope you can understand the nucleophilic addition reaction over here. Just a very, very kind reminder, we only focus on the carbon double bond O. Carbon double bond O becomes single bond OH and then add in a nucleophile. That's it. Simple. So let's move into another reaction, which is reduction of carbonyl compound. Reduction is actually the vice versa of oxidation. Alright, it's actually the vice versa of oxidation over here. So before we look at the reduction of your aldehyde and ketone, the first thing is, who is your reducing agent? We have 3 reducing agents that you can use. You can choose any one in these 3. The first one is your lithium aluminium hydride followed by H2OH+. When it's a follow by, what is meant by follow by is when you write on the arrow, you must have Roman 1 lithium aluminium hydride, Roman 2 H2OH+. That is what we mean by follow by. So whenever the word follow by, you must have your Roman 1, Roman 2. The next reducing agent is your sodium boron hydride in methanol. You must have the presence of your sodium boron hydride in methanol. Another reducing agent that you can use, very simple, hydrogen platinum. Your hydrogen gas in the presence of your platinum catalyst can also be a reducing agent. You can choose any one of these reducing agent. Okay, choose only one. Because all three of them will give you the same product at the end of it. Okay? So let's see how the reduction carbonyl works. The reduction of aldehyde will give you primary alcohol. I hope you can see the vice versa of it, because when your primary alcohol undergo mild oxidation, your primary alcohol will become aldehyde. So when your aldehyde undergo reduction, it becomes primary alcohol. Same thing happened to the ketone. So when the ketone undergo reduction, it will goes back to your secondary alcohol. Because when you oxidize your secondary alcohol, you will change your secondary alcohol to ketone. So your reduction and your oxidation is actually vice versa. Okay? It's very simple. It's actually exactly opposite of the oxidation. Don't worry, we'll look into example. So let's start with the reduction of aldehyde. Your aldehyde undergo reduction, become primary alcohol. Let's see what happened. So this is the example of my aldehyde. Focus again only on the carbon that holding C double bond O. Undergo reduction, you can choose any one of the reducing agent, and right now I'm choosing lithium aluminium hydride followed by H2OH+ acidified water. And guys, since we only focus on the carbon that holding the double bond O, what happened to the rest of the group? The rest of the group doesn't change. So we recopy everything that should remain unchanged. So leave it there. And this is the carbon that holding double bond O just now. And when it's a reduction, what happened? The double bond O will become single bond OH, adding in hydrogen. So oxidation means you add in more oxygen. Reduction means you add in more hydrogen. That's why you have your lithium aluminium hydride. And the only changes is happen to the carbon that holding double bond O. The double bond O becomes single bond OH. The same carbon adding in hydrogen to complete the 4 bond. Simple. And that is your primary alcohol. Because this is an aldehyde. So your aldehyde undergo reduction will become primary alcohol. Simple? I hope you can see that clearly right now. Let's try another example, another aldehyde. Same thing guys, we only focus on the carbon that holding double bond O. And when I undergo reduction, let's try with another reducing agent, NaBH4, sodium boron hydride, with the presence of methanol. And the same story guys, the group that doesn't change shall remain unchanged. So this is the group that doesn't change. This is the carbon that holding double bond O. So what happened to the carbon that holding double bond O? The double bond O will become single bond OH, and the carbon will have a new bond hydrogen. Okay, there's not enough bond because it's in the form of skeletal. The carbon over here is actually holding one more hydrogen. So you can put in the hydrogen, it doesn't matter. Okay, that is the hydrogen that is there from the beginning. The changes is your double bond O become OH, single bond, and getting an extra hydrogen. So you reduce your aldehyde to become your primary alcohol. It's a primary alcohol because this carbon is a primary carbon. Let's jump into ketone. It will be the same, but it's a ketone. So ketone will give you secondary alcohol when it undergo reduction. Let's look at the example. It actually doesn't matter whether it's aldehyde or ketone because we still focus only on the carbon that holding double bond O. And when this ketone undergo reduction, it will be the same because we only focus on this. And let's try reduction with lithium aluminium hydride followed by, so must be a Roman 1, Roman 2, H2O, H plus, acidified water. And we know that the group that doesn't change shall remain the same. Just copy everything exactly the same when it doesn't involve in the reaction. This is the carbon that holding double bond O just now. Okay? And what is changing? The double bond O will then become single bond OH and then having a new friend hydrogen. And I hope you can see that it's a secondary alcohol because this carbon right now holding 2R group. So that is your secondary alcohol. And that is because this is a ketone where your C double bond O is attached to 2 carbon group. Okay? And does it make any difference from your aldehyde just now? No. It's still the same where your double bond O will become a single bond OH and adding a friend hydrogen. That's it. Another example of your ketone changing to secondary alcohol in a ring. So that is your ketone. Because that is a carbon, that is a carbon. So holding the C double bond O. React with sodium boron hydride with the presence of methanol and ABH4 in methanol. Focus only on the carbon that holding C double bond O. The entire group shall remain the same. And we only focus on the carbon that holding double bond O just now. And what happened when the double bond O undergo reduction? The same thing, guys. The double bond O become OH, getting a new friend, hydrogen. Your ketone become a secondary alcohol because the carbon is a secondary carbon. Alright? And that's it for this video. And in this video, we cover 3 things. Why the carbonyl is reactive, why the C double bond O is reactive. Next, we talk about nucleophilic addition. Only 2 reactions. The addition of your CN minus nucleophile and the addition of OH minus nucleophile. And then we ended the video with reduction of carbonyl where we can reduce the aldehyde and reduce the ketone going back to your primary alcohol and secondary alcohol. Just make sure you identify who is your reducing agent. Okay? And the reaction is very, very simple. And I hope this video helps you a bit in understanding the nucleophilic addition and also the reduction of carbonyl compound. And if the videos helps you in your understanding, make sure you hit the like button and don't forget to subscribe to my channel for more videos. Thank you for watching and I'll see you again in the next video.